Okay, so yesterday we finished up section 1.1. Today we're going to look at 1.2. Basically, we're going to get into equations that have multi-step and also some equations that have variables on each side. Okay, so far we've only had variables on one side. All right, so that's what I just said. We're going to be using the properties of addition, subtraction, multiplication, and division, the properties of equality, to solve equations. So we already talked about that. The properties we covered the last 2 days, I just said them all. Okay, so you don't have to write those down. That's just what they are. Okay, every equation we do today, at least at first, will have 2 steps. There might be an example at the end that has more than 2 steps. But what we're going to do is just kind of go through some steps that you need to know to solve equations. So when you simplify an expression, right, we use PEMDAS. Okay, how many people have heard of that before, PEMDAS? Okay, just tells you the order to do things in. Well, when you're solving an equation, there's also an order to do things in. So we're going to go through that order, and it's just something you always want to follow. And what's nice is we can kind of simplify it. I can't really get it on the screen at the same time. Yes, I can. S-A-M. Okay, so we can simplify it. If you remember SAM, it's going to tell you the steps to follow. So the S is simplify. All right, so simplify. Under simplify, there's 2 things you have to do. Not every problem is going to have all of these steps. Okay? Some problems will, some problems won't. We're giving you all the steps. So no matter what kind of problem you get, you'll at least have...
Yeah, some stuff we do next academic week, well, these steps work for that too.
So the first thing under simplify is... nope, let me fix that. That is... these need to be reversed. So the first thing you always do under simplify is distribute. So if there's any distributive property in the problem, you always distribute first. So how would you know if a problem has distributive property in it? It's not going to say this problem has distributive property. Yeah, exactly, parentheses. So if you see an equation, something like this, the first thing you would do right there is distribute. Okay. Not sure we're going to get to distributive property today. I don't think so.
Today or tomorrow.
But eventually we are going to do some problems with distributive property.
Yeah, so because we're not going to get to it today or tomorrow, it won't be on the test. There's no distributive property on the test on Friday.
So again, distributive property. Sometimes we draw those arrows just to show distributive property. It's up to you. Next thing is combine like terms, which we'll just abbreviate CLT in the future.
So remember, guys, the big thing about combined like terms, they have to be on the same side of the equal sign. You can't combine them on opposite sides. That equal sign is like a brick wall. You can't go through that. All right? So they have to be on the same side and just add them and subtract them together, depending on what the sign says.
Yeah, so combine terms on same side of equal sign. So what would that look like? Something like this. I'm looking on the left-hand side. I see 3x. I see 1x. 3x and 1x are like terms. They can be combined together and just write 4x. Okay? So that's an example of combining like terms. So far, we haven't moved anything from side to side yet in the equation. The next 2 steps, the A and the M, that's where we're going to start moving things from one side to the other and using the 2 properties you learned yesterday and the day before. So, next 2 things you look at in an equation are any adding or subtracting you need to do. And remember, you always do the opposite. So if you see an equation that has addition in it, like 3x plus 2 equals 14, and you want to solve that, well, first thing you have to do is look and say, okay, I don't have any distributive property there. Don't have any like terms there. But there is some adding and subtracting I can do. Okay, I can move the 2 to the other side using subtraction. So I wouldn't worry about the 3 yet, because we can't get rid of this 3 with addition or subtraction. We can get rid of it with something else, but we're not there yet. So for now, we're focusing on the number that doesn't have the variable.
Yeah, this work, and again, this would work too if you had like variables on both sides. Right? If you had variables or numbers on both sides, you want to move the variable or move the number that has a lesser value. So you had like -7 and +8, you move the -7, because then you wouldn't be dealing with negatives. Again, like we talked about, guys, you may not have every step when we're doing these. Like the one Mr. Hager wrote up there, you wouldn't have to. There's only one variable, so you don't have to worry about matching up the variables, matching up the numbers. You don't have to do that. But again, something we get to later in the lesson, you would have to do that.
Okay, so what we're really doing at that step is we're just getting all the numbers without variables on one side, and we try to avoid negatives. That's what that's saying. If you can't avoid negatives, which isn't always possible, some problems are going to have negatives no matter what you do, then you just have to deal with negatives. Okay? But try to put all your numbers without variables on the same side. Avoid negatives if you can. So I think that's all we're doing at that step. We're not doing anything with the variable at that step.
What does that say?
There we go. So hold off on copying that down for a second. Yeah, you're just moving a number from one side to the other. That's it. So don't worry about that right now. All right, so now after you add and subtract the number, now you're going to have something like this. Okay.
Sorry, I think that meant if you had numbers on both sides. I think that's what variables on both sides.
Oh, if we had variables on both sides.
We'll get to that today.
Okay. So now under multiply or divide, that's the last step. And now in this problem, you would end up dividing both sides by 3. Okay, that's an example of what we did yesterday. So let me just see if I can try to give you something to put there. A little bit more. So,
Smart.
Yeah. So when you're doing adding and subtracting, what can we put on that line? So we've moved the number. You can also move, if you had something like this. Let's not make that a 2. Okay, so you start by putting all the numbers on the same side. So in this case, I would -8 from each side. That's good. But I still have letters on both sides. I don't want that. I want to get all the letters on the same side. So the next thing is you're going to move your letters all on the same side. Okay, and they have to be moved to the opposite side of the number. I think that's basically what we were saying. Yeah. So move the number with the variable to the opposite side. So whatever side you move things to in the first step, in the second step, you're going to move them to the other side. Okay, I can't really say always on the left because
Depends.
if you did this, yeah, it depends.
Depends on where that number is of lesser value as when you start.
So move number with variable to opposite side.
Do you want to put with opposite operation or no?
Sure. So move the number with the variable to the opposite side as the step above, and you use the opposite operation to do that. Okay, is anyone still copying down those steps? So we're not going to get to distributive property today. Combined like terms.
I think we may have one, maybe.
We have one in there. We're definitely going to get to multiplying, dividing, adding, subtracting. That's all going to be in the problems we do. Alright, so I'll take a look at this one, and then
You
you
go
want
back
to
to
do
that slide, that last slide, Mr. Hager, the last one, the steps. Guys, just for this, just so we know, you guys may know this, alright? Because we got a little bit of space, like 2 spaces underneath this. When are you going to multiply? When would you multiply? And at that last step, when would you multiply? What would tell you that you have to multiply?
If
Ellie?
there's a division sign, or
Okay.
like if you like
Close,
had
not division, but it's what's the number going to look
five, so
like?
if you had like a number with an X with like a number with an X next to it, you'd have to divide it. You know, like.
Okay, what kind of a number is it going to be? Is it going to be a whole number, Mary?
Fraction or a decimal.
Fraction, right? So we'll multiply when variable is a fraction. Make sure you flip it, right? So when the variable is a fraction, right? You're just gonna flip the fraction, multiply on both sides.
What about Mr. If you had something like that, variable as a fraction?
If you had
You almost flip that, right?
if you had something like this, right? What do you have to do?
Multiply the 10 times 5.
Yeah, we're just gonna go. This multiply by the number. That's all. You can almost treat that x as a 1 if you want to, but this multiply by the number that's on the bottom. Right? We do one like this. This multiply by 5 on both sides.
We did that yesterday.
Yeah, we did one like that yesterday.
Yeah.
And then, so multiply. When we divide, Ellie,
When the variable is a decimal,
on a decimal, you could do a decimal, but
or
what are we normally gonna see?
and it's like it's a negative number.
You could see a negative. Is it gonna be a fraction though?
Yeah.
No.
No.
No. What kind of a number is it gonna be?
Whole number.
Whole number, right?
Or an integer, right? It could be negative.
Yeah.
Right? Because whole numbers would mean it's only a positive. It could be, like Mr. White said, it could be a negative as well. But what you're usually not going to see is a decimal or fraction.
Wow, your handwriting's great.
That was bad, huh?
Yeah.
Gotta slow down, that's why. I do a little better. Alright, so then we divide again. This is kind of like this. That isolates what we did yesterday. That second step, add or subtract, that kind of isolates what we did on Monday. So all these things are kind of all coming together now. Alright? And again, guys, these steps, you won't need to copy them down again tomorrow. Alright? Because we're going to do some today. We'll do at least one today when there's variables on both sides. Because tomorrow we don't have the whole class period. We have half the time because period 2, you guys have the training in the auditorium. So that's why we're doing this today. So you won't have to copy down these steps tomorrow. You'll be all set. Alright? Everybody's good with this?
Yes, sir.
Dylan, you good? Alright, making sure. Alright. I'm gonna go back to. I do this, baby. Oh, I went full screen. That was the problem.
You want single page.
Yes.
Yep, so go right back to where you were.
That's what I was. There we go.
I'll do this one. You want to do one after?
Do whatever you want to do.
Okay, so this is an equation that has two steps. Okay, it's a multi-step equation. So first thing we want to do is just look at our steps, go through them, and just ask ourselves, okay, do we have this? Do we have this?
Yeah.
Okay. So the first step was simplify. What's the first thing you always do under simplify?
What are those steps? What are the steps? That makes sense.
Yep, Savannah? Distribute, yes. Nate, do I have any distributive property there? Okay, tell me where. And tell me how you know it's distributive.
No.
No, okay, tell me why not.
Really don't know.
Okay. Yeah, Miguel?
No parentheses.
There's no parentheses. Okay, no parentheses with a number on the outside, no distributive property. Next thing, combine like terms. Do I have multiple x's on the same side, or y's in this case? Do I have multiple y's on the same side of the equal sign?
No.
Do I have multiple constants on the same side of the equal sign? No.
No.
Maybe on
No.
the same side.
Nope, I don't have I don't have like terms on the same side, so there's nothing to combine. What's our next step after simplify, since we didn't have to do anything there? Yeah,
Addition or subtraction?
exactly. We're going to do addition and subtraction. Okay. Is there any adding or subtracting I can do here that would help me to get y by itself? Yep.
Add 2
Yeah.
to 2, and then add 2 to the 14.
So the goal is to get that by itself. We get rid of things with addition and subtraction that are near the y first. So we're going to add 2 to both sides. Negative 2 plus 2 is 0. 4y equals 14 plus 2, Matt?
You are.
It's 14 plus 2.
Oh, 14 plus 2, right? 16.
16.
And it's
Okay. Is there any more addition or subtraction that I can do there? No. If I had a y, don't write this down, but if I had a y over on that side, there would be. I would now have to bring this y to the other side. Since I decided to move the numbers without variables to the right, I would move variables that have numbers to the left. But in this problem, we don't have it. So there is no more addition or subtraction. So my last step is to deal with any, Yusuf? Division or multiplication. Is there any multiplication or division you can do here to get rid of that 4?
You can do division, you can just divide.
Okay. And by 4. Perfect. So now we get y equals. And what's 16 divided by 4? Savannah? 4.
And guys, in that step where Yusuf said divide, he's correct. Why wouldn't we multiply? Why wouldn't we multiply that? How do we know we have to divide? Again. You want to listen to that? Yeah, like Laurel said, there's not a fraction attached to the y. That's why we don't have to multiply. All right?
Do you want?
Yeah, great. All right. Somebody remind me, what's that, Nicole, what's that first step again? When we're solving an equation, what's the first step? Simplify, okay. So, Ryan, under simplify, right, there's 2 things. What's the first thing we want to check and see what we can do under simplify? We'll look at your notes. Flip your paper over. So we're looking at simplify. What's the first thing under simplify?
Distribute.
Distribute, right? Is there distributive property there?
Input.
Well, who answered that question? Who answered that question earlier about distributive property? Who was it? I forget. Was it? Yeah, Nathan. Is there distributive property there?
No.
Why?
Without parentheses.
Right, no parentheses, right, Ryan? If there's no parentheses, no distributive property, right? So simplify, distributive property. Catherine, what's the other thing under simplify? Do we have like terms? What do you think? No. Again, like terms mean what? What do like terms mean? What do like terms mean? Chris?
They're in the same category, like either like whole number or
Yeah. They're just regular numbers with no variables attached, or they have the exact same variables and exponents attached. We don't have that here. Alright? So don't simplify. Like we said at the beginning, sometimes we don't always have to do that first step. Alright? Or some steps we miss. Alright? What are we trying to get by itself in this problem?
Yeah.
The x, right? It has a over 5, but again, trying to get that by itself. Alright? So we did simplify, right? Dylan, after simplify, what step are we at? It's okay to look at your notes, you're not gonna get in trouble.
Oh, I
You didn't write it down?
distribute.
We did that part. We did simplify, right? Because we said we're going to either distribute combine like terms. Now we're at that next step.
Addition and subtraction.
Addition and subtraction. All right. We want to get the x by itself, right? So what are we going to do here? Are we going to add or are we going to subtract? Subtract what number? 9, right? So we want to get the x by itself. You get it, right? So subtract 9. Anyone else, Dylan?
From the 13.
From the 13. You got it. Good job. All right? This x over 5, all I'm going to do is just bring that down. I can't do anything with it yet. Bring my equal down. 13 minus 9. What is it, Donovan? 13 minus 9. 4. All right. Again, I don't have variables on both sides. I only have the x over 5 on one side. So I don't have to move anything else. I'm done that part. All right. That step of add or subtract, I'm done. There's nothing else I can do. All right. Gigi, what's my next step?
Multiply.
Multiply or divide, right? In this problem, what am I going to do? Multiply. Why? How come? Why am I doing that?
Because it's a division.
Yeah, I kind of have, like, this kind of looks like a fraction. You know, the x is on top, it kind of looks like a fraction. So I'm going to multiply. Multiply by what number, Gigi?
5.
5. 5 here. Anywhere else? Both sides, right? Just like when you add and subtract, we do it on both sides. Alright? Alright. The whole reason I did this was to cancel it out so I can get the variable by itself. And then 4 times 5, Ellie?
20.
20. Now hold on. Look at the directions for this problem.
You have to check it.
Solve and check. So these these 2-step ones we haven't had to check yet. But again, on the test, make sure you pay attention to the directions. Like I told you guys all week. You're not going to have to check all of them, but maybe 4 or 5 of them, something like that. So just make sure you pay attention to the directions.
So, guys, quick question. When Mr. Roy crossed those 5s out, just put a line through them, what number is still left in front of the x? 1. 1, exactly.
Yeah, there's always a 1 in front of that x. We just don't write it every time.
Yeah, because some people have said, oh, it's 0. No, not 0. No, it's still a 1 in front of it.
Yeah. How would I write that out to check it? Donovan?
20,
Yeah.
25,
20 over 5
plus 9
plus 9
equals 13.
13. Now I just simplify, right? Melanie, what can I simplify?
You can simplify the fraction.
Okay, which comes out to what number?
4.
4. Because remember, like I told you guys, a fraction is really just a division problem. This means 20 divided by 5, like Melanie just told us, it's 4. You can
Wait, I
figure.
have one question.
Yes, Mr.
How come, I thought with the order of operations we said we always do addition and subtraction first. How come we did the division first? I thought that was the last step.
Okay.
You were asked that question.
Right? Division's always supposed to be the last thing we do. We just did it as the first thing. How come? Yeah?
Because when you simplify it, it's still the same thing. You just changed it. So, I don't know how to explain it, but it's the same thing as 20 over 5.
Are you saying that if you subtracted 9 on both sides first, you get 4 and then you still get 4? Is that what you're saying?
When you subtract 9 on both
Yeah.
sides, you
So what Melanie's saying is this: I do 20 over 5 plus 9 equals 13. If I minus 9, I'll get 4 here equals 20 over 5. When I do 20 over 5, like we just said, you get 4 equals 4. It'll still check out. All right?
It still doesn't quite answer my question, though. You're lucky. In this case, it does work, but it won't. Yeah. In this case, it did work. Yeah.
Because when you do 20 divided by 5, you're not actually doing the division, but you're just simplifying the fraction, putting in those terms.
Okay. What are we doing in this step?
Yeah. Are we solving an equation here?
Exactly.
You're
Donovan?
solving an equation, you're not solving, or like, you're not finding out what x equals. And so it does, it's PEMDAS, it's not the other.
That's exactly what I'm getting
It's
at.
not SAM, it's PEMDAS.
There's two different things, right? This is PEMDAS. This is not SAM. SAM is when you're solving an equation.
Yeah, same.
Okay? PEMDAS is when you're just doing arithmetic. We got it? So, two different orders of operations. Don't use PEMDAS when you're solving an equation, and don't use SAM when you're doing arithmetic. Okay? But that's, we are correct. I just want to make sure people understand why.
Now we get 4 plus 9. That's going to be 13 equals 13. It checks out. All right. So again, another one where there wasn't equations on. There wasn't variables on both sides. All right. So again, not super tough, but 2 steps. All right. Now this one, we're telling you, this one's going to need to be simplified before we use a property of equality, before we add, subtract, multiply, divide. So what does that mean? What are we gonna? Wow. What's one thing? There's actually 2 things we may have to do with this problem. What's one of them?
Combined like terms.
Combined like terms is one. What's the other? Gigi? Distribute. I may get, again, I'm only going to get one of them. I won't get both. All right, we're not at that point yet. All right, so we're either going to have to distribute or we're going to have to combine like terms. This is it. 9f plus 4 minus 7f equals 8. I'll give you guys a second to write that down. Like we said, we'll have to simplify, and Donovan and Gigi told me the 2 steps that we'll have to do one of those 2 in this problem.
Question?
And I know what we do.
Jake, what are we going to have to do here? Are we going to combine like terms, or are we going to distribute? I'm going to go to my resident expert on distributive property in the back corner, Nathan. Is there distributive in this problem?
No,
No, there's no. How do you know? Tell me again.
there's no parentheses.
There's no parentheses. All right, Jake. So we know there's no distribute. We know we're not going to distribute. What's our only other choice?
Combine like terms.
Combine like terms. Can you tell me the 2 like terms in this problem?
9 and 7.
9 and 7, right? Is this a positive 9 or a negative 9, Jake?
Positive.
Because there's no sign to the left of it, right? So that's that. What's the other one? And tell me the sign that's with it. What's the other like term?
Negative 7.
Negative 7f. Very good, right? Because it's to the left of it. Jake, when you combine those 2 things, what do you do?
That's
What do you get? What do you get? It's 9. Basically, it's 9 minus 7. What's 9 minus 7?
Yeah.
Not sure? Brain's not full, not on the
No,
go
no,
yet?
no, no.
Savannah will help you out. Savannah, go ahead. 2f. Now, here's what some people do. Guys, when they're on the same side, just do what the math says. Just do 9 minus 7. Don't do more than you need to. A lot of times I'll see kids plus 7 here, like they'll go plus 7. Don't write this because it's wrong. Plus 7f. They're on the same side. You don't have to do the opposite operation. Just do what the signs tell you to do. Combine the numbers and then you're done. You don't have to do the opposite operation when they're on the same side. I see people make that mistake all the time. So we did that. What I like to do is, again, if you circle them to identify what the like terms are, that's fine. You don't have to. I do it just because it helps me. Gone, gone. What else should I write? Ellie?
Plus 4 equals 8.
Plus 4. The stuff I didn't use, I just brought down kind of like this word. That's common sense. I understand, but some people do forget that step. They get stuck. They don't know where to go. All right. So now, I've done the simplify part. Alright? Someone raise their hand and tell me what I'm going to do. Actually, before I even do that, what do I want to get by itself? Matt.
F.
I want to get the F by itself. Don't have to do this. Again, it helps me. I'll put a box around it because I know I don't want to do anything with that yet. I want to get that alone on one side of the equal sign. I don't want to touch that at all. Alright? Yusuf?
Would you do like -4?
You would do -4. That's perfect. -4. Well, so -4. Yusuf, -4 from 8 as well, right?
Oh, yeah.
Yes. Alright? All I'm going to do is just bring down the 2F, because I couldn't do anything with it. And Yusuf, 8 -4.
Oh,
Got it. I'm at the last step, right? Page, what am I going to do? Divide by 2. I got a whole number attached, right? Don't try to make it more difficult than it is. We don't have to deal with fractions. There's no fractions there, we don't have to deal with them, alright? Just divide by the whole number that's attached to the variable and do it on both sides and you're good. That cancels out. Leaves me with F. Like Paige told me. I'm going to get 2. Now this one says check. Alright? This one says check. So, if I was to write it out, alright? Because I have some variables next to numbers, right? So when I write it out, what might I want to use to write when I write it out? Donovan?
Parentheses.
Parentheses. Donovan, tell me what to write.
9.
Yeah.
2 in parentheses.
Yeah.
Plus 4. -7. 2 in parentheses equals 8.
There you go. So all we did was, and again, you can write it out and put like 9 with a little dot to show multiplication, and then 2. I wouldn't suggest doing like a 9 times 2 plus 4 minus 7, something like that. I wouldn't do it like that. Why wouldn't I recommend doing it that way, like using like X's? All right, Chris?
Because it looks like you have another variable.
Yeah, it looks like variables, right? You might get confused. The best way I think is to use the parentheses, right? 'Cause remember, when there's a number and a variable next to each other, that just means multiply. 9 times 2, 18 plus 4. A negative times a positive is what? Negative. 14 and 8. All right. I got 18 plus 4, 22, minus 14 equals 8. If I was to, just so you guys can see it, 22 minus 14 equals 8. 8 equals, it checks. So we're going to ask us to check that one, so we checked it. That was one we had to simplify. Again, no distributive property this week. We're not going to get to it, we won't get that till next academic week. So no distributive property, but you will have some combined like terms. And we may do one tomorrow where you have to combine like terms on both sides of the equal sign. Alright? Oh my god, what did I do? Okay. Now this last one, I don't think we're combining like terms, but we will have variables on both sides, which you haven't seen yet. So like what we do right here, guys, this is like the stuff for tomorrow, 1.3 part 1, but we want to do one today. That way you guys got all the steps you needed to do these, and we don't have a lot of time tomorrow.
We have a word problem too.
We have a word problem too. Alright, so variables on both sides. Here we go. So, first thing we have to ask ourselves is, can we do what? Ellie?
Simplify?
Can I?
Yeah, no.
No.
But you can do distributive.
Why? I can distribute?
Yes.
Resident expert, can we distribute?
No,
Why?
there's no parentheses.
No parentheses.
Oh,
Right. He's like the expert, like back there.
whoops.
Right? He's a distributive expert. There's no parentheses, we can't distribute.
What?
Can we, what's the other thing? Distribute, what's the other thing we check to see? Savannah? Combine line terms, can we?
Yes.
What's the rule for combining like terms? Where do they have to be?
On the same
You
side.
gotta be on the same side. Like I told you, when it's like terms, this is like blocking it. You can't do that. Alright, we're gonna match them up at some point. We're gonna do the opposite operation, get them on the same side, but not right now. Alright? So no combine, no simplify. So now we're at add and subtract. So this is when we get into looking at, we want to move the number, just the number, not the variable, the number that has the lesser value. Alright? So Miguel, what's one of the numbers in this problem? Tell me the sign with the 2.
7, 1.
That's a variable. I want just a regular
Oh,
number.
13.
Huh?
13.
Positive or negative?
Positive.
Positive. So there's one of my numbers. No variable, just a constant. Right? Positive 13. Haley, what's the other number? I had a positive 13. What's the other number? Tell me the sign with it. Negative 3. So like we talked about, that step that we wrote, the first step under add and subtract, we talked about moving the small one, but it probably was kind of confusing to you guys up until this point. Because before, we only had like one just number with no variable attached. Now we have 2. Alright? So now we want to move the one of lesser value. Remember I said before when we're combining like positive and negatives, take the sign of the bigger, ignore the signs at first. Whatever number is bigger, take that sign. You don't want to do that here. You want to pay attention to the signs. You want to move the one that is lesser value. So we got positive 13, negative 3. Bethany, which one has lesser value? Positive 13 or negative 3? Negative 3. So I want to move that. How am I going to move it? I want to take this, I want to match it up now. I want to take this and get it over here. So what do I have to do to it? To get it from here to over here. What operation do I have to use? If there was like an X attached or something, yes, I would divide. I want to like get rid of this. I want this to cancel out. It is subtraction, so I want to get rid of it. Add, right? So use the opposite operation. Plus 3. Again, those lines in this there to show, maybe I'll put them in boxes so it'll make more sense. I'm just putting the boxes around these guys just to show that they're both numbers so we can isolate and see, okay, which one's smaller. So like Bethany just told me, all right, we're going to add 3. We're matching them up now. We're just going to add 3 to the 13. Why couldn't I add the 3 to the 7-1? Matt, what do you think? Why couldn't I add the 3 to the 7-1?
Because it's not a like term.
Yeah, it still works even when you're like moving stuff around. They have to be the same to combine them together. They're not. I can't do it. Okay? Gonzo. Alright? Do my math here. Nicole, when I do my math here, 13, positive 13, positive 3, what do I get? Positive or negative? Positive. You said negative at first, didn't you?
She said positive both times.
Both times, okay, I'm getting old, I can't hear so well. Positive 16. I have to write the sign because there's going to be a number or a variable that comes before it. So I want to write the sign so I know. You can't just put 16 because you don't know if it's positive or if it's negative. If it was like the first number in the problem, you could just write 16 because it wouldn't need the positive sign. But because it's in between another number, you got to put that positive sign so you know. Everything else, I'm just gonna, the equal sign included, I'm just gonna bring them all down. 7y plus 16 equals 5y. Now, sometimes when I get to this step, I say to myself, which one of those things is not like the 2 others? Which one of those terms is not like the 2 others? Matt?
The 16.
The 16. Why is it not like the 2 others, Matt?
Because it doesn't have a variable.
Again, it doesn't have a variable. This is not moving. Alright? That positive 16 is not moving. You already moved it around. You already did that stuff. You already moved all around to get it where you want it to be. What you just moved around to get to that point, the number, you don't move that. This is like almost like a flip-flop. Alright? You brought something over here in the first step. Now you're in that next step, So you're gonna take something from here and move it over there. It's like you're flip-flopping things. Moving your numbers to one side, variables to the other. So what do I have to do to get the variables on the same side? Matt?
Subtract
Subtract what?
the 7y.
Subtract 7y. Minus 7y. Minus 7y. I wouldn't divide. People I say, well, it's got a 7 attached. Why wouldn't I divide? I can only do that when I have a variable on one side and a number on the other. I don't have that yet. I'm one step away from that. All right? This is just going to cancel out. I did that to get the 16 by itself. The whole goal with this is when you get to that, before you solve, before you get to that last step, you want a number on one side, a variable on the other, or vice versa. Variable on one side, number on the other, nothing else. All right? I'm going to bring down the 16, because I did nothing with it. You can put the plus sign now if you want, but because it's the first term now, you don't need it. We know that there's no sign to the left of it. We know that it's positive. Yusuf, what are you going, man?
I said like 5 minus 7y would be -2.
-2.
-y.
Again, let's explain. I'm going to explain it. 7, if I'm ignoring the sign, or we can even do it the other way. 7's bigger than 5. All right? 7's negative. Like we talked about last academic week. We take the sign of the larger number. All right? It's negative. Then I just read it from the bigger to the smaller. Make it something that you understand. You understand 7 minus 5. 5 minus 7, some people are like, oh man, that's different. That doesn't sound right. That's why you don't have to do it this way. Again, I think it makes sense to me. I think it makes sense to some people. While some people might be like, Mr. Roy, what the heck are you talking about? I have no idea. Like if my wife would hear, she'd probably be like, what are you doing it that way for? Like, they can just do it. My wife used to be a math teacher. She'd probably be like, what are you doing that for? They can just do it. You know? But again, I like to read it, identify which number is bigger, put that sign, and then read from the bigger to the smaller. 7 minus 5 makes sense to me. As long as I put the sign first, I'm good. 2, and like Yusuf said, make sure you put the y. All right? Laurel? Hello? Can you tell me what to do as the last step?
Divide -2.
Divide by -2 on both sides. Perfect. Then it's a whole number. The number attached to the variable. I want to divide by that number. All right. So now I have a positive divided by a negative.
Is it negative?
Correct, Yusuf. It's going to be negative.
Even though that 16th bigger than -2, it's still going to be a negative?
Yeah. Looking at the bigger and the smaller number. All right. We'll only worry about that LE when we're adding and subtracting.
Okay.
When we're multiplying, the rules are the rules. All right. Negative, negative, positive. Positive, positive, positive. Negative, positive, negative. Positive, negative, negative. Right? The rules are just the rules. That's how it works. All right. So we know it's negative. And then we're just doing 16 divided by 2, which is going to be what, Dylan?
No, 16 divided by 2 is 8.
Nice job. And then, like Yusuf told us, these just cancel out. And we get y equals -8. It doesn't say to check it. We don't need to. I'm not going to make you because it says we don't have to. I don't want to do extra work. So that right there for today is the last 2 that we did in example 3 and example 4. As far as equations are as hot as it gets. All right. Now tomorrow, like I told you, we'll do some of the equations. We'll do some of the variables on both sides. Maybe on both sides you may have to combine like terms. But like I told you, no distributive property this week. We won't get that till next academic week. So we got one more, then we're done. Right? We had a different. Do you guys have that one on there?
No, we have
We had a different one.
We have the one about the pizza.
You have the one about Donovan and Yusuf.
Okay.
Yeah, that's my pizza here.
Oh, why? All right. You gonna type that on there, Mr. Hager? Okay. I don't know what happened there. Yeah. So like I said, guys, I'm gonna try to by this afternoon, guys. I'm gonna try to by this afternoon get the reference sheet posted for you guys, so you can start going back into your guided notes and find the examples you have to write on there. Tomorrow night, homework, test review. Remember, like we told you guys, on there, there'll be all examples that are similar to what you're gonna see on the test. So basically, like the homework we give you tomorrow night, it's just like we go on to the computer program that makes the test, and we go to a problem and we hit the space bar. Because that just changes the numbers. It's the same exact setup, but there's different numbers.
Go, Joey.
I don't like charge $100 for each.
And I use you guys.
He only charges the $1
the names we had on in the state are from like 2 years ago.
And
We had Cy and Bailey.
And then he needed to fix the other one because it's Pixar.
He wants it like that. He wants PIXX. Pixar shop.
Pixar shop.
It's fixing it. All right. So Donovan's Pizza charges $10 for cheese pizza and $1.50 for each additional topping. Yusuf's House of Pizza charges $12.50 for a cheese pizza and $1 for each additional topping. Write and solve an equation where you would pay the same amount for a pizza from each place. Okay. So let's look at Donovan's first. All right. What are we going to start? So we're going to set up an equation, right? What are we going to start with? What should I write first? What's the first thing in that sentence that's kind of important? Ellie?
Charges $10 for cheese pizza.
All right, so what should I write?
$10.
10. I didn't have to write the dollars. I'm just going to write 10. And Mr. Hager just highlighted it for us. I'm going to write 10. For a cheese pizza, okay. Mr. Hager, he's getting ready to highlight the word and. What does and translate to in math or in algebra? Donovan?
Addition.
Addition. So I got 10 and means addition. After that addition sign, David, what am I going to put? $1.50. Now, this is where your algebra comes into play. How many toppings are we putting on the pizza from Donovan's place?
Like put a variable like X.
Yeah, we don't know how many. Perfect, Yusuf. Nice job. We don't know how many we're putting. We're just going to put X. So we could plug in any number of toppings there and get what it costs for a pizza from Donovan's Pizza Shop. Alright, so we got that. We're good. That's Donovan, right? I'm right above it. You don't have to write this, I'm just showing you. We took that sentence for the pizza from Donovan's, right, and we translated it into algebra. That's what we got. 10, the and told us plus, the $1.50 was just there, and like Yusuf told us, we'll use X because we can plug in any number and get the price. Okay. So, actually, I'm ahead of myself here. Let's go to Yusuf's. It's going to be the same way, right? What are you going to start with, Ellie?
We're going to start with $12.50.
$12.50. $12.50. There's that word, there's another word again there that tells us what to use for our sign or our operation. What is it? And. Jake, what does and mean?
Addition.
Addition, nice job. So we're going to put our plus. How about Miguel? How much are the toppings at Yusuf's? $1, right? I'm gonna write it as $1, true dollar. And then, how many toppings did I put, Chris?
You don't know.
What should I put?
X.
Very good.
Here we go.
Okay, so we're close, but I need to make this an equation. What's it missing right now? Yes, it has variables. Great, that makes it an equation, but it's missing something. Yusuf?
I'm done with talking.
That's okay.
Okay.
Donovan?
The equals.
The equal sign. Alright, so then we got, I want to put Yusuf's. I want to put Yusuf's over here. You don't have to write this, I'm just showing you. There's Yusuf's. Where should I, so Donovan just said, I agree with him. He said you're going to put an equal sign. Where? What do you think, Savannah?
In between the 150x and 1250.
Yeah, because we want the value, like Mr. Hager highlighted in green, we want the value, whoa, he's blacking it out now. We want the value to be the same. Same means equal. Alright, same means equal. Okay? Now, this type of problem, is this just a basic two-step, or is this variables on both sides? Variables on both sides. Alright, what's one variable, Yusuf? 150x, right? That's one of them. Alright? Paige, what's the other one? 150x is one variable. What's the other one? $1, right? And they're both positive, right? Because the sign to the left is positive. Again, you don't have to do this. I just do it so you can see it. So we get to this point, right? We get two variables on either side. I guess what's kind of the rule? Ellie?
That you have to combine like terms.
I can't combine like terms because they're on opposite sides.
Okay. So when
Kind of along that lines, we can't just do we can't do positive 150 plus $1.
Okay.
That won't give us what we need. We got to start moving stuff around. Mary, what do we want to move?
Do you want to move the 10 over to the other side?
You can do that too. I mean, it doesn't matter. You can move the variables first. You can move the numbers first. I don't care. So Mary said move the 10. Why not the 1250, Mary?
Because then you have a negative number.
Exactly. That's why we say move the one that has a smaller value or a lesser value. Positive 10 is less than positive 1250. So I'm going to move that. Mary, what operation?
Subtraction.
Subtraction. Minus 10. I'm going to minus 10 from 1250. All right? This cancels out. I got 1250. All right? I got 1250 minus 10. What do I get? 250. All right. I'm going to bring down the 1x. I haven't done anything with it. I'm going to bring down the equal sign. I'm going to bring down the 150x. Again, notice how the plus sign disappeared. It's the first term in the equation. I know it's positive. I don't want to put any extra signs because it's just going to screw me up. All right? So we're close now. What thing that I just moved?
The 10.
The 10, right? This is where my move happened, right here. To make that by moving stuff around, that got me to the 250. Well, 250. All right? So where the move just happened, right? Whatever's on that side still needs to be moved. So what's on that side now that needs to be moved? Ellie?
we can move the dollar.
The buck, right? How do I do it?
Subtract the dollar.
Subtract the buck. Make sure I put the X, okay? Then I'm going to minus the dollar from what, Ellie?
From both sides.
From both sides. What's on the other side?
150.
150X. Does that make sense? So, it's like I said, it's like a flip-flop. You move stuff over here. To balance it, now you're going to take that and move it over here. That gives you variable on one side, number on the other. Alright? When I do that, I got $1.50 minus $1. What do I have left, Ellie?
0.50.
0.50.
X equals 250.
I'm going to bring down the 250. One more step. Catherine, what's that last step? I got faith in you can do this. You don't have to tell me, just tell me what operation you have to use. Divide. Do you know what number to divide by? 0.50, yeah. I'm going to divide by 0.50. Right? It's not a fraction, it's a decimal. I can still divide by that. I'm going to divide by 0.50, 0.50. All right? Cancel out.
Try to think, how many times does 50 cents go into $2.50?
5 times. So X equals 5. Now let's go back on what did it ask? Oh, so we did too much, Mr. Hager.
Oh yeah, we should solve it though.
Oh yeah, write and solve an equation. It did say that, I'm sorry.
Yeah.
Write and solve an equation where you would pay the same amount. So it asks for two things. Here's your equation, all right? And then when you solve it, x equals 5.
5 what? $5?
Yeah,
No.
5 toppings.
for toppings.
Exactly.
Yeah.
So when you put 5 toppings on a pizza from Donovan's and 5 toppings on a pizza from Yusuf's, it'll be the exact same price. Even though the cost of a straight cheese is more, like I think it was at 10 and 12.50. If you put that many toppings on, that's when it'll be the exact same price. All right. So as far as it goes, all right. Tonight's homework, 1.2 part 1. I think I put 1.3 part 1 as well, because we did some of that stuff today with equations on both sides. The worksheet. Again, some of you guys didn't have your binder yesterday. I gave you the dividers. Again, on your own time, because if you haven't, make sure you set it up. A great time to double check your binder, because a lot of you guys, again, when the test is done tomorrow, guys, you're done. We have nothing more for you. You've done enough this week, taking notes, doing warm-up, doing problems at the end of the lesson. So once you've done the test tomorrow, you're done.
Test on.
I'm sorry, Friday. Once you've done the test on Friday, once you've done the test on Friday, you're done. We have nothing more for you to do. All right? So a good thing is, as you're sitting there, if you haven't set your binder up yet, take the time to go through your stuff and get it organized. All right? Google Classroom, guys. Again, we emailed you guys the code. You have the sheet from the first day of class. Get on there, check it out. All right? I'm hoping by this afternoon, I'll have the reference sheet up on there, so you guys can start going back into your notes and getting the examples you need. First test, Friday, not tomorrow. Everybody chill out. First test is on Friday. And remember, we only have half the class tomorrow. We're only meeting from like 7, well, you guys are here at 7:45, till 8:30. When they're gonna start calling us down for that Alice training. Like we had an intruder in the building, had to go on lockdown. They need to go over that with you guys. So we're only gonna have period 1 tomorrow. Notes are gonna be really short.